In this video, I want to continue describing a popular quantitative approach, conjoint analysis or trade-off analysis, for getting customer input for product design. The key idea is that rather than asking customers directly, we infer their preferences from hypothetical choices they make. I will present an example. The format will follow an example used by Ron Wilcox from the Darden School of Business. To help you understand what you can do with a conjoint analysis study, consider this stylized example product. The product is a video conferencing platform for large meetings. The qualitative work determines several features to include regardless of the final product. There are three attributes still under consideration: brand name for the service, the maximum number of participants, and the price per room per day. The brand names and their levels are shown here. We call this a 4x3x4 design, which corresponds to the number of levels for each attribute. Assuming each attribute is independent, a 4x3x4 design requires a minimum of 16 product profiles be shown to a respondent. The 16 are cleverly selected, usually using tables defined decades ago. Each respondent rates all 16 product profiles. DIY software such as Qualtrics can be used to collect the data. To the left is what a respondent sees if you use Qualtrics to collect the data. The respondent rates each product. The right panel shows the data in Excel. Column 1 is the rating data from Qualtrics. The first product was rated 72. Going across the row, the remaining columns are dummy variables that get turned on for each attribute level that was part of the product. For the first row, we see there are ones for the brand name Congress, the capacity for 500 people, and the cost of $250 per day. We use regression to estimate the part worth utility of each attribute level. To set up the data, we leave out one level for each attribute. The left panel shows the data set with conference, 500 per day capacity, and a price of $250 left out. We use Excel's regression tool to estimate the part worths. The second panel is the dialog box showing the commands. The third panel shows the coefficients estimated from the regression. The intercept is the total utility of the option left out, i.e. brand name is conference, 500 capacity, price is $250. The coefficients are deviations to the total utility of the left out option. The rightmost panel is the results. We've added rows showing zero values for the attribute levels of the option left out. Going forward, we are interested only in the relative utility of one alternative over another, so we could ignore the intercept. This also means it does not matter that some coefficients are positive and some are negative, since we are only interested in differences between their values. To see this, assume we added 100 to every coefficient. They would all now be positive, but their differences remain unchanged. Interpreting the output. To the right, we have copied over the part worth importance weights we obtained from Excel. This is our data. For each attribute, we graph the part worth importance weight or utility for each level. For brand name, it is clear from the bar chart that Conference and Congress dominate. Next, we expect utility to increase with the maximum capacity. Notice that the line graph suggests that there is decreasing marginal returns. The utility gain going from 700 to 900 is lower than the gain going from 500 to 700. Finally, we expect utility to decline with increasing price. This is the case in the bottom right panel. Every $100 increase in price is associated with a decline of approximately 6 utility points. What can we do with this? First, we'll consider the individual level, or if you want, think of it as an average over a group of relatively homogeneous respondents. Then, we'll briefly discuss what can be done using conjoint analysis data from multiple respondents. Number 1, preference. For the next few slides, we'll be using the part worth data, so we've pasted that on the right side to make it easier to refer to. Assume there are these two products in the market. Which is most preferred? Simply add up the utilities of each attribute. In this case, minus 1.75 is greater than minus 4.5, so we prefer the product on the right. Number 2, attribute trade-offs. Considering the product shown, should the manager pursue an additional 200 in capacity to get to a maximum capacity of 900 attendees, or a price reduction from $750 to $500 per room per day? The price decrease is worth a utility increase of 8.5, whereas the capacity increase adds 6.5 to utility. Since 8.5 is larger than 6.5, the respondent prefers the price cut. Number 3, attribute importance. The idea here is that little variation in utility over an attribute's levels means it has little importance. Put differently, say if the utility for red color is about the same as any other color, then color has relatively little importance in determining preference. So, more variation, operationalized as the range of the utility of an attribute's levels, means it is of a higher importance. For our video conferencing example, how important is price? The relative size of its range is 0.43, so its relative importance is 43%. Number 4, willingness to pay. Consider the product shown here. How much would the customer be willing to pay for an increase in capacity from 700 to 900 participants? This is more complicated than what we've considered earlier. First, we must calculate how much a utility point is worth in dollars, then use that to convert the utility gain from the capacity increase into dollars. Note that we aren't restricted to the attribute levels tested. For example, if you are willing to assume that utility is a linear function between 700 and 900 participants per day, we could interpolate the value for a capacity of 800. First, determine how much a utility point is worth in dollars around the change that is being considered. The price is $750 per day, so let's evaluate over the range $500 to $1,000. We find that a utility point near our change is worth about $75. The utility gain from 700 capacity to 900 capacity is 6.5. 6.5 times $75 is roughly $100. Number 5, choice simulator. We need a choice rule to translate preference utility into behavior. Consider 2 broad decision contexts. The first is an infrequently purchased high involvement product category, like buying, say, a refrigerator. In this situation, we assume the buyer always picks their favorite from the choice set. We call this rule first choice. The second is a frequently purchased low involvement product category, like, say, buying a household cleaner. Here we assume that the buyer can pick any of the options, but in proportion to some function of the utility of each. We call this share of preference. Since utility is not constrained to be greater than 0, we use a transformation called the logit transformation that maps any real number to a value between 0 and 1. We call this rule share of preference. We also include a scaling constant. Small values of the scaling constant push the predicted share to be closer to the relative size of the utilities. Larger values of the scaling constant push the predicted share to be more like the first choice rule. For existing markets, we would choose a scaling constant that resulted in the best prediction of the current market shares. Let us assume the individual is choosing between these 2 products. What share will Colloquium get? Well, it depends on the choice rule we assume. Under the first choice rule, Conference's predicted share is 0 as its utility is smaller than Colloquium's utility. Under a share of preference rule, its share will be roughly in the range 10 to 20%, depending upon the scaling factor. Which choice rule is appropriate for a video conferencing service? I think most people would find a service they like and stick with it, so a first choice rule seems appropriate here. An appealing feature of conjoint analysis is that we get individual level preferences. From the choice simulator, we can aggregate individuals to get a market prediction. One thing we can also do is group individuals into clusters based on their preferences, usually using their attribute importance weights. In summary, asking customers directly about their preferences often leads to unenlightening answers. They want everything and to pay very little. Conjoint analysis is a method to elicit customer preferences inferentially by having them make choices of hypothetical products. If you conduct conjoint analysis studies regularly, say as part of a consulting practice, consider using commercial software from a firm called Sawtooth Software. This concludes this video.